This is the final topic in graph. We're going to learn about intercepts. And if you have watched my previous video, I recommended you to buy a grid note or grid papers and have it ready for this session. It's not a must, but having a grid paper will save our time a lot because it'll be much easier to draw the graphs. But even if you don't have it at the moment, you can still go through the video, so don't worry. Before we start, I mentioned in the last video that I'll be showing the answer for the homework that I assigned to you. It was to draw a graph for y equals minus x. This is the solution. As you can see, when we have a negative slope, I told you that this is the slope value in front of x. When it's negative slope, which is in this case is minus 1, the line goes up from the right to left. Do you see it? This is because when we input our negative numbers here for the x value, this negative sign here outside of the bracket that was already there in the function flips back the sign. So the y value, which is the height in the graph, which represents the height, flips upside down. So from this, we can learn that when we have a negative slope value, it could be minus 1 or minus 2, minus 3, etc. The line will move up to the left. Okay? So that was a lesson from the homework. Now let's learn the intercept. Graph the following functions. I have two different functions here. One is y equals x plus 1 and the other is y equals x minus 2. So the difference is plus 1 and minus 2 that's coming after x. Now, here are my two grid papers. So I'm going to be using my ruler again to draw the x and the y axis from the middle. So if you don't have the grid papers, that's fine. You can still draw the axis on the blank paper, not a problem. But just try your best to make the x and the y axis be perpendicular to each other. Make sure of that, okay? So I'll be drawing the x and the y axis using my ruler. Oh, by the way, let's not forget to put the arrows here like this. This is the x-axis and this is the y-axis. Now, I'll be putting tick marks on each end of the squares on the axis. Like this. So when we have the grid paper, we don't need to go by 1 centimeter, but we could just use these boxes. So I'll go like this. 1, 2, 3, 4, 5. But if you don't have the grid paper, you could simply use the ruler and put tick marks on every centimeter line, just as before. Okay, so let's have this ready. We'll need at least 10 by 10 squares or 10 by 10 centimeters for our graphs, okay? As you can see, this time I didn't draw the last column here because I believe that you can calculate all these in your head. I'm not expecting too much from you, right? So let's fill in the numbers by using these functions. I hope you got the same numbers as mine. Now we'll identify the locations of these dots. So we have 1, 2, 3, 4, 5, 6, 7 dots. Oh, by the way, every location here on the graph can be expressed in terms of what we call a coordinate. And we express a coordinate as x, comma, y with a round bracket. Yes, x value comes first and the y value comes next. So, for example, let's say we have a point here. The coordinate of this point is, what did I say? X comes first, so 1, comma, 2. This is the location of this dot. X equals to 1 and y equals to 2, right? So this is some extra knowledge that you have to remember. But for now, I'll just erase this again and start graphing. Did you get the same line as mine? You can also do the next one. Then we'll discuss about these two graphs, okay? Check if you got the exact same lines. Now, I want to know if you remember how the function y equals x looked. Y equals x, the one that didn't have any other numbers in the function, but simply y equals x. Do you remember? This is how the function looked, right? We had a line that was passing through the center point and had the 45 degrees inclination. But y equals x plus 1 seems to have moved 1 unit up from there. We can see that happening to all the dots we drew. Do you see it? So this dot got moved 1 unit up, this one as well, and this one as well, like this. And here we have x minus 2, so it makes sense that the line went 2 units down in this case, because it's x minus 2. Now, I'm going to talk about the most important one today, the intercept. Intercepts are the points that touch either the x-axis or the y-axis. If there's a point that is touching the x-axis, for example this one, we call this point the x-intercept. If there's a point that is touching the y-axis, such as this point, we call this point the y-intercept. Please take a note. It is very important to know where the x-intercept is and where the y-intercept is. We can write down the x and the y-intercepts in terms of the coordinates that I explained you just before. So our x-intercept in here is going to be -1, 0, which again means the intercept lies on where x equals to -1 and y equals to 0. Our y-intercept in here is going to be 0, 1, which again means it is at where x equals to 0 and y equals to 1. Now, pause the video for a moment and try to determine by yourself the x and the y intercepts in the second graph. The x-intercept in this graph is at 2, 0, and the y-intercept in this graph is at 0, -2. I hope you got it right. So let's review. X-intercept is the point where the line meets the x-axis, and y-intercept is the point where the line meets the y-axis. Simple as that. But we have a very interesting fact here. So, according to these definitions, x-intercept should always have the y value of 0, and the y-intercept should always have the x value of 0. Why is this so important? If you're going to school or taking an online course right now, this could be asked to you in the test. Let me explain. Question 1. What are the slope and the x and y intercept of this function? We have y equals 2x plus 5. Now, what did I say about the slope? The slope value is shown in front of x. So, we already found that the slope should be 2. Now, how can we find the intercept? As I just said before, x-intercept is when the y-coordinate is 0, which means the height is 0 on the graph, and the dot is touching the x-axis. So, if we plug in y equals 0 to the function, it's gonna be 0 equals 2x plus 5, because y equals 0. So let's do some math. If I move 5 to the other side, it's going to be minus 5, and we'll be left with 2x on the right hand side. And if I divide both sides by 2, it's going to be minus 5 over 2 equals x. So that means our x-intercept is x-intercept, I'll just write it short, is going to be minus 5 over 2, comma, 0. And we'll check this soon. When we are finding the y-intercept, we assume x equals to 0. Why was that? It was because the dot shouldn't go left or right if it wants to keep touching the y-axis, right? Correct? So, if we plug in x equals to 0 this time, it's going to be y equals 2 times 0, because x is equal to 0 at this moment, plus 5. So, 2 times 0 is 0. Therefore, y equals 5. That means our y-intercept should be at 0, 5. But can you believe this? We answered everything already when we didn't even draw the graph yet. Now, let's check how the graph looks. This is the graph for our function y equals 2x plus 5. I used the bigger paper because the y-intercept was all the way up here. And also, I know my graph looks unbalanced, but that's okay. I'm interested in the left region, so that's why I drew the left side more. So there's nothing wrong about that. Anyway, let's look at the slope. It's pretty steep. Now, every after block, so let's say from here, the line goes 2 blocks up. So 1 block and 2 blocks up, right? So that does sound like we got a slope of 2. So our answer is correct. Now let's see where the intercepts are. Where's the x-intercept? Here, right? It's in between minus 2 and minus 3. So that's minus 2.5. Oh, isn't negative 5 over 2, same thing as negative 2.5. And the height is 0, of course. So we got it right. What about the y-intercept? Where is it? Right here, where it's touching the y-axis. And that is indeed at the coordinate 0, 5. So we got them all correct. One last very important lesson here. Before, we saw that when we had y equals x plus 1, the line looked like it moved 1 up from the y equals x line. So because of that, we had the y-intercept at 1, right? And when we had y equals x minus 2, the line looked like it moved 2 down from the y equals x line. And because of that, we had the y-intercept at negative 2. So if we look at this function, we have y equals 2x plus 5. And we see that our y-intercept is at 5. We have a conclusion. Mathematicians write functions using this form. M is the slope value and B is related to the y-intercept. So when we write down our y-intercept, it's going to be 0, something, and that something is simply going to be this b from the function. But what about the x-intercept? I know it sucks, but we can't know x-intercept right away from the function. You will just have to put y equals to 0, then find what the x value should be. But there's gotta be some work to do, otherwise anyone would get 100 on the math test. It's gonna be too easy. So that's how it is. Slope and the y-intercept, we can find it immediately, but not the x-intercept. But you know how to find the x-intercept, so we're all good still. Here's the homework for today. I'll be showing the answers in the next video, in which I'll be teaching elimination and substitution. I hope you enjoyed the video and see you next time.